This time on Captain Castle's Laboratory, we're working on Mickey's Magic Toy Chest, which is an old Enesco. I'm not really impressed with the sounds I hear when I took it out of the package. This doesn't open, it's supposed to open mechanically, so that's it. And when you plug it in, it does not sound good. So something has come apart prior to being shipped to me, and possibly even more in the shipping to me. So we're going to open it up and see if we can figure out what's going on. So the only access on this is going to be on the bottom. There's 1, 2, 3, 4, 5, 7 screws. There's 5 big ones, 2 small ones. I'm assuming these 2 small ones hold the spot where the power and on-off switch are. So I'm going to take out the big ones first and see if it'll come off. I'm going to have to use a good old-fashioned manual screwdriver for this. Those are tight. So those 2 are plastic screws or coarse thread screws. This middle one is a machine screw, which usually indicates it screws into the mechanism. And it doesn't want to come all the way out, but it's out far enough, I don't think it's going to go back in. So we're going to find out here in just a moment. There we go. Alright, there's no movement, so now I'm going to take out the 2 smaller screws. That screwdriver is too big, so we'll go back to the little guy. There's 1. There's 2. Let's see if we can get this machine screw out that doesn't want to come out. There we go. No other than the switch screws. It's very possible that the mechanism is only held in on the bottom, that it might come out the top like some other Enescos. What I'm trying to do is access this little plate I just unscrewed and see if I can get it to come out. It seems to have a seam all the way around, whereas the big red plate doesn't. Except I can't get anything in there to pop it. There we go. Just a piece of glue there. Alright, now we can see so it does look like everything comes out the top. So this blue plastic right here that's screwed into has separated from the red. The red does not have a seam around the edges, at least not one that's visible. And if I put a little stress on it with the pick, all it does is try and open the top. So It probably is a top load similar to, yeah it is, yeah it is, similar to the mailbag one, or Santa's gift bag. There we go. Yeah, the whole thing's going up. Just trying to get a broken figure out, which is right there. And there we go. I think she's caught on the wires now. Set it this way. Now, whatever was in here, it looks like it caught fire. So we have a completely melted resistor, a blackened wire with no insulation left. Yeah, this thing got real hot. So something in here let go. I'm going to try and move some of these wires on top of the blue plate so I can show you what I'm seeing, so you have an idea. So, and this also might free up some of the wires so I can push them or pull the center out. Let's see, I see some screws that hold the mechanism to the blue plate. We got 2 screws there. We got a really deep screw that goes all the way up. So anyhow, before we continue, let's flip this thing over like that. And I'm going to show you what I was looking at. So that is what's left over of a resistor right here. It's all melted, and I don't know if this is going to make it too bright. Yeah, a little bit better. So that's what's left of a resistor. That's the insulation, or the color bands. The black is the resistor. The ooze is the silica getting hot and melting. And then this wire here is burnt, and this wire here is missing its insulation, which is also burnt off. There's some of it right there, and corroded. And then this wire is completely burnt, which is this wire right here. It goes all the way up and around, and it stops right about there, and then it starts right there again. So, yeah. Something in here let go. And that may not be the reason why it doesn't open and close. That's a completely different story. But I need this to completely come out. It's most of the way there. I'm hoping there's some slack on the wires, because there'd be really no way for them to put this together if there wasn't. Oh, here we go. I see some gears. Don't go back in. Other part of it is it's getting caught on the hinges, which are pressed on. So there's some of the gears. Let's zoom back out. Well, the hinges have a Phillips screw, but I have no idea how you get to them because all the stuff that's on top of this is in the way. So there's a screw here, and a screw here. That's a press pin, and that's a press pin, and then the sides look like they're kind of sort of permanently attached, probably with glue or resin. The rear hinges are also pinned on. I wonder if I can drift pin out the hinges themselves. So let's see if I get that to close up a little. So there's a pin, like a standard hinge that goes all the way through. This one's sticking out a little. I don't know if I'll be able to grab it. No. I'm wondering if I can tap the hinge pins out since I can't get to the screws. I don't think I have anything that's small in here, but I'm going to check. That pin is halfway out. Now let's see if I can knock this one halfway out, and then I'll try and walk them out so I can get the lid up and off. Sounds a lot more violent than it is. I'm not tapping very hard, and I'm only hitting the small metal drill bit. Putting little holes in the head of my hammer there. Alright, now let's see if I can pull it out with these. If not, I'll use a different pair. Yeah, I got no grip with those. Let's try these. One hinge pin. That's two hinge pins. All right. Now I'm caught on the wires, but I have the majority of it up. Put that back there. So the off-on switch is held in with two small screws. Here, we'll push that in like so. Now the power port has a recessed nut, or I mean it is a nut. It has two pin holes in it that you can put a spanner plier in, but this actually does fit inside, surprisingly. so I can unscrew the right now it's turning the whole thing, so I guess I better hold it back so I can actually get it to unscrew. There we go. So like a lot of these power ports that protrude through, where they have a silver ring, that silver ring is actually a nut that holds it in. And that silver nut's now somewhere on the floor. Probably lost forever. Shouldn't be. I just cleaned the floor, so I should be able to find it pretty easy with a flashlight. Alright, and voila! So there's the empty box. And we now have the mechanism. So if you have this piece, you are going to have to bring out the top. You are going to have to unscrew it. That machine screw actually does hold the music box player in. It's one of the three, but it also holds the blue plate to the actual box itself, so you do have to actually unscrew it. Now let's take a look at all the components in here, because it does have a circuit board. And something caught fire, so now we need to examine this. It's a basic circuit board. I don't see anything burnt on the board. It's got two motors, one for the music box. Oh, excuse me, it's got three motors. One for the music box, one for the lift and lower, and then of course one that makes the characters work. Now that we have it completely out, I can remove some more of this glue snot and get a closer look at what happened here. So it is the, wow, the hot and the not, so the positive and negative are both burnt. So the positive that goes to the off-on switch is the one that caught fire. The positive that goes directly to this bar that it just broke off of. The heck does that power? It's a very interesting little thing. This doesn't make any sense. Are these mechanical switches? They are. Holy smokes, look at that. It's got mechanical switches. Now, most switches are mechanical, but these are fingers that are separated by an air gap, and when things move, it presses and closes them and opens them together. It's got a cam. It's got two cams, as a matter of fact. Some old school engineering in this. Let's just take a look at all the gears. I don't see anything broken. I don't see anything wedged. I don't know why it's having a problem, but I'm going to have to trace that wire that burnt and figure out what it went to and try and find the cause. Things can fail just for no reason, but that's pretty rare. This is so weird. They have sponges as cleaners and noise dampeners screwed into the gears. The most unique thing I've seen in a long time. Oh. My concern is once I get it working, because of the music box and it's Disney, if it's going to play something that's copyrighted. And it's my bigger concern right now. As far as functionality, yeah, the lift and lower, well, lowers, can I lift back up? Yeah. Is it moving the bar? It is. Okay. When it moves the bar, is it moving all the gears? Because it shouldn't. I think there's a broken gear in the lift mechanism. So I'll zoom in, but the motor over in this corner where my hand is the lift. The motor over here is the player. The motor right here is the motion. So I'm going to tip it over so you can see what I'm looking at. I know you can't see. And I'm going to zoom in and point to things just like I normally try and do. Get my little pointer here and zoom in. So we'll zoom in a little bit, let it focus. Maybe. There we go. Alright, so this is the motor that drives all the characters on the top to make them go back and forth and spin or whatever you're supposed to do. This motor drives the bar, which drives, that's your music. That's your little, your bumps on the metal barrel that make the fingers go ting, ting, ting in the different tones. And then, behind this piece of plastic is your lift and lower motor. Right there. So when you push this up or down, which you shouldn't be able to do, this bar goes, it spins all these gears. There's a worm gear right there. You cannot turn a worm gear from these gears here. These gears were turning, which indicates that either one of these gears is broken or that worm gear is broken for the lift and lower. Now the mechanical fingers I was talking about is right here. Here's one, there's the other over here, sorry. And then see, these are cams. Those cams make contact. So this red wire that's broke right over here was soldered right here and it snapped off when I opened it up. And there's that burnt resistor. So this red wire goes to the switch and then it has the output. So I need to trace it and see what on the other end of this wire got so hot that it smoked the resistor. And then this wire I'll just have to be resoldered right back here where this solder glob is right there. Not a big deal. And then the ground, which I broke off as well, it broke off over here. Actually, I think that's the hot. But right there, that solder glob, and it's this black wire right here. So, yeah. So let's back the camera back out. Wherever it is, that's too tight. There we go. So that's where we're at. So what I'm going to do now is try and trace the red wires. So this one goes to the switch center. So no matter which way you flip this switch, it's going to send a signal to something. So if I flip the switch to the right, this red wire is soldered to the other side, which then goes to a green, a black, and a yellow. So yellow and black go to the musical motor, and green goes to the circuit board, and also a red wire. So the red wire splits. There's two red wires. One goes over here, one goes over here. Green over here, which is the circuit board. Yellow over here. The black also splits. It goes to that motor and over here because you need a ground for everything, and it also goes up to this motor. So either this motor's overdrawing or this something in the circuit board failed. So on this circuit board, tip it this way. It might be harder to see, but you see that thing with all 4 pins? I believe it's a power. The name's escaping me. I can't remember. It's a Motorola. Let me look it up. Power regulator. That's what I was thinking. It's an AN6651. Let's look it up. See what it comes up as. It is an integrated circuit for DC motor speed control. So it's classified as a transistor, and it runs between 3.5 and 14.4 volts. And it has built-in reverse voltage protection. Generally losing audio equipment. It's not really an audio equipment, but it is a music box, so I guess it's technically audio. So I did check the power supply. This is a 9-volt unit, and the power supply is putting out like 12 volts with no load, which is just fine. Power supply is working. So I'm wondering if the motor died and shorted out. This one. We're going to test them all. First want to get the solder off this finger and see if I can get this wire reattached so I can actually test the lift mechanism properly, because if it's got a broken gear I need to know so I can start looking for it. Looks like Mickey can just be glued back on. You can see the glue residue. I'm waiting for the soldering iron to get hot. I don't remember seeing her, but I'm sure Minnie's up in there, and here's her bow from between her ears. I still remember Goofy, but I don't remember seeing Minnie, but I'm sure she's in there. Let's move those all the way over. So, those who don't know, that's a flux pen. I'm going to try and use that to get rid of some of the solder that's on the finger here. Help. So I can scrape it off and wipe it off. And let's see if I can get this hot enough to put some more fresh solder in its place. Because of the size of the finger, it acts as a heat sink. It doesn't allow the solder to bond so well. But looks like it did decently. So how it looks to me, and I'm probably wrong, but how it looks from what I can see mechanically and electrically is the power goes to that finger, which means it energizes the lift motor. Once the lift motor is all the way up, it makes contact on the other end, on this side, where the fingers touch and make a connection, which then engages the rest of it. Probably the motion motor. I'm sure the music box plays pretty fast. Most of them that come across the music boxes are hardwired, where they turn on no matter what. That's why I'm wondering if the reason it doesn't work is because the motor's bad, and that's why it was just making a funny sound. And I think the clacking that I heard was a lift motor trying to lift, but it's got a broken gear. So I want to solder that on because, for two reasons. One, I won't forget where it's at, and two, I can disconnect by cutting the motor wire that's burnt, which powers this side, and just have the lift motor do its thing. So I can test it that way through the fingers. So I'm going to go ahead and cut off, because I need to figure out what this resistor was, because it is blackened. There's nothing left of it. So I need to solder the other wire back on so I can actually send power into the unit. Then I'll test the other motor independently. I'll just use my machine and give it some power and see what the motor does. The machine will tell me if it's shorted out, or if it's super high draw, it'll make a high pitch beeping sound. Trying to strip some off this wire. The wire is smaller than my stripper, so I'm just trying to use the side cutters, but this wire is really brittle. I think I got it. I did. Finally. All right. Solder with hot glue on it, so I'm just going to use a soldering iron to melt the hot glue and then wipe it off. The soldering iron is hotter than the hot glue. There we go. Now I can solder this on and I'll have a circuit again. Come on. There we go. Got it. Okay. More hot glue. Oh, I said it was 9 volts. It's DC, just so you know. It's not an AC unit. Because the motors aren't synchronous. Usually the only time you see AC units on Enesco or the Department 56 in general, or Mr. Christmas, and even a few of the other older style Emaxes, if they have synchronous motors. Synchronous motors are AC. They do make synchronous motors or DC, but they're not very common. Alright, so one of them is clacking. I think it is the lift motor that's clacking. Yep. Lift motor's clacking. Looks like the motion's working. Yeah, motion's working. Which is weird. It's hard to do this with fat fingers, I guess you could say. Trying to see everything, because I can't turn it off by the switch because it has a reset, which means it still tries to run even though the switch is off. It's in the on position right now. I'll flip it to the off position. It still should try and run. Yeah, it's playing Mickey. That's hopefully not going to be copyrighted. Okay, so the motor that's clacking is actually the motion. No matter which way I push the switch, it doesn't turn off. Alright, so we got a broken gear. So apparently the resistors for the lift motor. I must have traced it wrong. Which is possible, all the wires are the same color. Let's try this again. So the wire goes in here. Where is the wire that goes to this? That's that red wire. Yeah, it's probably I traced it wrong because there are multiple red wires. And what's this one? This one. This one goes over there. I truly don't know. lift motor is red and green. Green's right there. Ooh. These gears are going to be really hard to find. Hopefully it's the worm gear that's broken. But, alright. I really wish I could get this cap off. Why they? I don't know how they got the screws on the inside. That's crazy. Let's see if I can pull the pins out. I really need to get this lid off. I really do. Alright, here's one. I said they're just pressed pins. Alright. The reason I need to get the lid off is because I actually need to turn this on its side so I can watch the gears, because there's so many of them. And I can't do that with the lid because the characters will hit the lid. Slightly harder one to separate. Let's turn off the siren. There we go. You gotta remember this is a hinge, so as I'm trying to turn it and pull it out, it's trying to open and close the lid. So I'm supporting the arm with my fingers, which I'm not probably use these because the characters are in the way. And then I'm just turning the pin back and forth while pulling out until that entirely long pin comes out. It's a lot longer than I thought. So basically I'm supporting everything because it's plastic and pulling on the brass pin. Oh, that is a really long pin. Okay. Really wish it would stop slipping though. Pins. There we go. Much nicer. Yeah, there's Minnie. And then her bow was right there. Okay. So now I can set this down at a slight angle. Like that. So I can watch everything. Yep, it looks like the broken gear is right up here in the front. Can I turn think it's the main drive gear, not the worm gear. Worm gear might have damage, but I need to just tap it slowly here. Yep, it's cracked. Okay, so it's got a little, looks like it's a 10 tooth that's right off the worm gear. So let me zoom the camera back in. First, let me get the light out of the way. Turn it off. There we go. And bring this thing back down. There we go. Okay, so that's the worm gear. And the worm gear, you can kind of barely see that gear right there. It's right behind the worm gear. It's right next to this gear. It actually drives this gear. It's got a crack in it, which looks like a standard 10 tooth. So this whole thing has to be disassembled to get in there. The worm gear looks like it's damaged, but it could also be all this dried grease. All this white stuff is just, you can see on the screwdriver tip, it's just dried grease. So I can't tell if it's actually damaged or if it's just hardened grease on the drive. So at 40 minutes in, we are disassembled. We have found some of the reasons that it's having issues. Mainly, we've got a fire, so I need to figure out what the resistor is going to be. The music box part plays fine, which is good. That's good to go. So we have a broken gear off of the motion mechanism, and then something wrong with the lift lower mechanism. Something caused it to get super hot, which could be a bad motor, could be a motor that's trying to turn when it's not needed to turn anymore, meaning that when it's at max lift or max lower, the motor's still trying to turn, but the mechanism has stopped it, meaning those fingers aren't, the contacts aren't separating. Let's see if I can show you the contacts. They're pretty interesting the way they have this done. That's the easiest way to show it to you, because I can see with my eyeballs. Doesn't mean the camera is going to see it because of the shadow. So let me zoom it back down again. I don't know if there's going to be too much light, but we're going to try it. It's not bad, because the camera picks up light differently than your eyes. So you can see the two bars right here. Of course, I'm going to catch it out of my hand. You guys see the screwdriver fits between them. Right here, very almost unnoticeable. It's kind of this little spot right there. That's a contactor. So when that cam rotates, it pushes the metal bars together and makes contact. When it rotates the other way, they separate. That's the contactor. So what I was saying is I'm wondering if when this completes its motion, that it's not connecting. It's not pushing those bars down and still connecting, where the motor is trying to turn, but it can't because it's being held in place by the entire mechanism. The mechanism's done. It's at max top or max bottom, and it's sitting there, and that motor says, and then it gets hot. Motors don't like that. Motors stay cooler by spinning. When they're not spinning, they get really hot really fast. When they're under load, they get hot. But if they're freewheeling or moving like they're supposed to, they stay cool. And I'm wondering if that's why this resistor burnt. If this motor is bad, or if this motor is just trying to run all the time. And of course, I would normally just put power directly to the motor, disconnect it from the circuit by desoldering one of the two wires, but the connection's right behind this bar. So it means you got to be fully disassembled to do everything. But I think it's also got a broken gear, because I was able to raise and lower this. You saw me when I opened it. I was able to push it closed like this, and when I open it, those gears move, and they're not supposed to. I shouldn't have been able to move this at all without the gears breaking into pieces. So I have a funny feeling we got some broken gears in here. I'm going to check the main drive gear first, which is this big guy. If that one's broken, that's going to be a problem. The problem with a lot of these gears are, they are standard hobby gears, but it's the size. So the tooth is the same, but the diameters are different, which of course different diameters means It may not fit, or by too small or too big, or the teeth count's different and you move quicker or slower, or the teeth mesh is different, meaning the angle of the cut of the teeth is wrong, and then the gears just strip themselves out. So many things. There's so many things that can cause a problem. It's kind of amazing. But let's try and get this thing apart even more. So let's see if we can get to this piece first, because we know it works. We just know it's got a broken gear. There's 1, 2, 3, 4, 5 screws. That's all I see are 5 screws that hold the mechanism on, right? 1, 2, 3, 4, 5. Yes, 5. And because of how high in they are, I'm not going to use the electric screwdriver. Plus, I think I need to charge it. I think it's getting a little weak. This, well, I mean, that screw could fall through, it doesn't matter, but there we go. Here's the second screw. So far they're all the same, so it doesn't matter which order you take them out in. That was too small for the screwdriver, so there we go. That's the gear that appears to be broken when I rotate it, so I want to double check it. Oh yeah, it's split. Okay, so that is definitely broke. Now I want to check the gear next to it. Sometimes a split gear can damage the teeth of the following gear because it's jumping. It doesn't happen often, but you should always check all your gears and also look for any fractures, especially on something this old. So this gear is good. So let's put it back in. Beyond this gear, the following gears are going to get really difficult to find if they're broke. But because of their size, they're much larger teeth gears. You can physically see them all. The only ones you couldn't see was this one and the other one I just pulled out. So if there's a break, you'll be able to see it. What you need to do is measure the diameter and then check your ratios when you go online. And yeah, the worm gear is damaged. It's got an hourglass figure cut into it in one spot. So it's been jumping. So it needs a worm gear, and I think this is a 10 tooth. Let me count it real fast. So we're going to start at the brake, which is right there. It's really obvious. It's either a 10 or a 12. 1, 2, 3, 5, 6, 7, 8, 9, 10. It is a 10 tooth. So, alright, so this has a 10 tooth and then a worm gear, which the 10 tooth is cracked. The worm gear is got some of the gear itself is peeled. So I'm going to zoom back down so you can see it. Going down. Focus. There you go. All right. So you can, if you slow, be able to tell right in this area, right in here. See, there's a piece of it missing right there. So there's a flat spot. And then you see it's all thick, and then it gets thin again to the flat spot. So there's some minor damage to the worm gear. Minor damage doesn't get better, it will get worse. Fix it, especially if you have it open. Here is the 10 tooth. I'm going to use a pair of pliers to hold it. And that is what's cracked. And the crack is, there we go, at the 12 o'clock position. You see the black line right there, pretty much straight up. That's your crack. This gear is pressed on, which means I shouldn't be able to slide it off. That's pressed onto that shaft. So that's another way to tell a broken gear, is usually the gear will spin freely on the shaft. The way it's captive in here with the bushings, it's actually got bushings, so be careful when you take it apart. That's why I took this off slowly. Is these little flat, clear discs with the bushings that put pressure. The pressure was allowing it to turn. Probably wasn't turning at full speed. You probably did have some slip on this gear, which I didn't realize was off camera. So the bushings are still stuck up in here and not on this. There's no bushings. You can see all the holes for the gears, which are there and there and there. There's no bushings on them because they set the plastic to the right height to give it positive pressure. But there are bushings on this side of the gear, on the ones that go through those two holes. You can see the bushing mark. You can kind of see that circle. So make sure you don't lose your bushing. They're very thin. Actually, there is one bushing. It's right here. It just came off the gear. So that's on the bottom side. So I was wrong. There was a bushing. I just didn't notice it until I took it out. But see how clear that is? Yeah, really easy to lose. They're about the thickness of a piece of paper. And they are really hard to find. So try your best not to lose it. If you do, find yourself a piece of thin plastic that's rigid and make a new one. Sometimes it doesn't matter. Sometimes the gear you get might be slightly taller and it'll take up the space of the bushing. So maybe that'll help you. But try not to lose those bushings. Alright, I'm going to zoom back out. So I'm going to get my gear kits and we're going to see about fixing this up real fast. Putting this together, testing the mechanism out, make sure there's more clacking and it works right. And then we got to figure out what that resistor is. What is that resistor? And then of course we have to kind of open this up so I can get to the back so we can test the motor. So I'm going to pause it for a moment while I get some gears and do all that since, excuse me, we're 53 minutes in. And I want to find some stuff and not waste your time while I'm searching. And then we'll come back and see if we can get this thing to the next stage. This can be a long repair. These music boxes are very complicated. Not really, but very, can't think of the word at the moment. A lot of moving parts, very basic in how they function. But you have, this is 3 segments. You have a top segment, a left segment, and a right segment, or if it's flipped the other way, they'll be switched. But the point is you have to deal with each piece individually. We know that one of the 3 sections is good, which is the music box. We know that this has 2 broken gears. Well, a broken gear and a stripping gear because of the broken gear, because that tooth is clicking and wearing the plastic now. And then we have to deal with this, which is not only possibly a bad motor, possibly some broken gears, and definitely an electrical issue. So we're going to save the more parts part to last. And then we'll continue. So, and then of course putting it back together is going to be fun. Putting those press pins in and all that. It's all tedious, small work, but it can be done. Alright, I'll return here in just a few moments. Okay, we're back with the toy chest. There's the broken gear, and actually that gear has also got a hairline fracture in it. It's not only just tapered, which you can kind of see right there from wearing on this gear, it has also got a fracture. So it would have given out anyway. So just to show you, I reassembled the gears and put the little spacers in just to save on some time. So there you go. All the characters are moving, just like they're supposed to. And we're going to stop it because it's copyrighted music, so we're not going to play a whole bunch of it. So I'm going to throw these away. They're trash. So it's got a new worm gear and a new drive gear. All the other gears are good. Like I said, I reassembled it just to save a little time. Now we need to work on this motor. So 2 to 3 now function. So we're 2/3 of the way there as far as repairing. We know that this wire goes over here. So we got to figure out why it's burnt. Why did this burn? Why did that resistor burn? And what was the value of the resistor, or approximate value of the resistor? So what I'm going to do is we're going to disconnect the wires from this motor, and we're going to test the motor. I want to see if the motor works. If the motor doesn't work, that's the problem number one. If the motor does work, problem number one would be what caused the motor to fail. So I'm going to see how much slack I have on these wires, and I'm going to remove the protective glue. Alright, come on. Because if I can, I want to do it while the motor's still in here. The reason being is the load. It's going to have a load on it, which is going to give me more information about the motor. If it's over amping, if it's can't turn, if it's seized. Whereas if it's freewheeling, meaning there's no stress because you pulled it out, it may show that it's working just fine. But without a load, you're not going to have... That is some nasty glue. But the wire broke. I was trying to avoid that, but that's okay. We'll fix it. There's a lot of glue in here. There we go. Alright, so all the glue was on that connection there, and there was a little bit on the connection up here, which is right there. So I should have enough room to tap the machine to it. The problem I have is I don't know the voltage. And the reason I don't know the voltage is because of, I don't know how they have this all set. So I might have 9 volts in, but only sending 2 volts to the motor, or 3 volts to the motor. What I'm going to do is I'm just going to, especially with the one wire disconnected, I don't have to worry about backfeeding the board. I'm going to connect the connection to the green, and I'm going to tap the red, or vice versa, whichever is easier, at a low voltage and see if the motor moves. Because I also don't want to break anything because it's already at full extension, which means if it keeps trying to go up, it might break a gear. And the motor is reversible. It's a DC motor, which means when voltage is going in one direction, it raises, the other direction it lowers. Technically, the little finger should stop it from doing any damage, but Murphy likes to live around here, so you never know what's going to happen. So I'm going to start off at about 3 volts. These motors here, this style motor, generally will run as low as 1.5. Some of them are 3. So we're going to start at 3, and I'm going to connect the red to the bottom where the red wire was, and I'm going to do the ground to the green. I hear the motor, but I think it's at max height. I think this is the lift position. Where's that connection? Yeah, it's at lift position. So I'm going to just reverse my connections here to make it easy. Like so. And I'm going to go to drop position. And it doesn't want to move, which means that something in the drive is probably broken. Yeah, it broke. Something broken. If I tip it on its side, you might be able to see this. This is the problem with doing small gears, is trying to see things. So I'm going to lower the camera, or zoom in. Whee, going down. Give it a second to focus. There, we're going to slide it over. So here's the gears. I'm going to turn it at an angle. So, oh, you can see the brake. See the broke right there? Broke. Jeez. I speak good English. So there's our brake. Right there. So this whole thing has to be disassembled. But since I know it's broken and it's not going to bind, what I want to do is see what... So under a load at 3 volts is pulling 3/100 of an amp. So I got a little of a baseline there, which means that at full voltage, meaning 9, which I doubt it gets 9, I'm going to say it's probably getting about 5. That seems about normal. It's probably going to pull at 5 volts about 6, 0.06 or 6/100 of it. I'm just going to touch it real quick and see what it says. So I'm going to do 6 volts, or 5 volts, sorry. 5 volts. There we go. 0.06. So, show the motor's testing okay. I'll still do a better test on it once we take it apart. Let me get these out of the way. Alright. I'm going to zoom back out once I find a little button. That's tighter. Probably don't want to look at Donald Duck's butt there. So, now we need to disassemble this because we have a broken gear and I still want to test the motor. So I want to get it all apart. We're going to see what's going on, see what we can do, try and get this all fixed up. It's almost done. Hopefully everything works once it's fully done and I can send it back. It's a pretty neat little thing. I'm not a big Disney person. It's just me. But it is kind of a cool little toy. It is copyrighted music. I don't know if it's copyrighted music in the sense that it's the music box, but I know that the Mickey Mouse theme song is copyrighted. I don't know if they would hit me for a copyright on the actual music box, but I'm going to try to avoid that if I can. So, how do they put this in? They put those screws in there. It is interesting. That's how they did it. Alright. So there's 2 outer screws, there's 2 matching screws on the other side. Really can't get in there, the angle's wrong, and there's no holes in the top to slide a screwdriver down. But this whole top slides off with a total of 4 screws. Now we're going to do that, and there's notches right here for me to rest the screwdriver. So it slides off. If I can get them to break free. That's one. Might have to use a slightly better screwdriver. Let me see if this one will do it. So that's a 1.5, and this is a 2. Meaning the size. It's a micro 2 and this is a micro 1.5. So this bar we're moving not only holds it on, it's also what allows this pin to go back and forth for raising and lowering. There's one on the other side too. What am I doing? Just use this. To make sure we don't lose the springs. So I'm going to put the springs inside the music box. And the reason I put them in the different areas of the music box itself, move them around so the springs don't get caught on each other. So I don't know if you ever had springs get tangled up. They're really a pain in the butt to untangle. So now you have a better view of what everything is inside here. So now we're going to remove this screw and that screw, so we can remove this gearbox assembly. Where it is. Yeah. Technically this should just lift out. Technically. And there we go. So I'm going to cut the green wire, and what I'm going to do is, sure you all figured it out. Green on the top. So I have half a dozen colors in my desk, so I can, or workbench, desk, so I can mark the screws. So now we're going to take this gearbox apart. There we go. Okay, this motor has a part number on it. So if you're interested, this is an FF series motor. It's an FF130SH. So here's those. Here's that one. And then the one that's cracked is actually supposed to be pressed on. It's still kind of pressed, but not as strong as it used to be because it's cracked. Didn't crack all the way though. So it cracked through the teeth and it cracked part way into the nose, but not the whole way into the nose. So I am going to have to pry it off, or at least get it to where it cracks all the way. Come on. Alright, so this gear has a very long, fat nose. It's like a step gear, but it doesn't have teeth on the end. That might pose a small problem because they don't really come that fat anymore. I'm sure there's some out there. Oh wow, this gear has a hole in it. It's breaking apart, so we're going to replace this worm gear too. Check these other three. Good. This one's pressed on, so the shaft is permanently stuck on it. Still good. There we go. So I'm going to have to look for this gear. But what I want to do now is I want to test this motor again before I replace anything on it. So I'll put the red on the red and the black on the green. When I say that is because on the back of the motor there's a red dot, which usually indicates hot, but it's a reversible motor. This is just hot, so it spins in usually the clockwise direction. So with no load, it is pulling 0.400 of an amp at 5 volts. 9 volts is pulling 1/10 of an amp. So I'm going to bring it back down to about 4 volts because that's pretty fast spinning. And I'm going to take some of the grease off of it and then do a load test. There we go. So that's rocking. It doesn't have a hole in it. It just has some black stuff inside the grease that makes it look like there's a hole. It's shadowing. But I'm going to check to see if it's cracked. But I need to get more of the grease out. There we go. Oh, that's much cleaner. Now I can see the whole gear. No cracks. It's not even hourglassed. It looked damaged, it's just the amount of grease that was built up on it. Alright, now we're going to load test it, and how you load test it when there's no gearbox attached is I'm going to put it at 5 volts, because that's what I think it's supposed to run at. Again, I could be wrong. So 5 volts, and then I'm going to compress it with my finger, and she stalls at a 1/2 amp. So 5 volts, it drops to 4.7, 4.5, and goes up to 0.6 amps. So just over 1/2 amp when it actually shuts off. What's nice is if this has any data online, we can look up this part number and find its rating and its optimal run voltage. They'll always give you a range, but on their rating it'll tell you 4.69 volts or 3.74. I mean, it always has some weird number. It'll give you an optimal range. So, let's look it up. FF130SH. Wow, this motor at Walmart.com is $27. On AliExpress it's $2, just to give you an idea. Alright, so the rectangular compact brush DC motor made by Mabuchi Motors. Okay, don't care. Alright. This motor is rated 3 to 12 volts. There we go. From 3,900 to 14,500 volts. Says average voltage is 6 volts. So I was doing 5 because I figured I was going to be pretty close. Doesn't mean that that is the correct voltage that this puts out. This could put out 3 volts. This motor says not to run below 3 and do not exceed 12. And it runs as low as 3,900 RPM. That's here at the armature, and up to 14,500. It says that a lot of things these are used in are shavers, small personal massagers, toothbrushes, audio video players, RC models, and robotic projects are the most thing. And it says normally it's run on a battery, either 3 volt battery setup, 2 AAAs, 2 AAs, 2 Cs or Ds, or a 9 volt battery, 9 volt. So, but it says optimal running range for this motor is 6 volts. That's what I needed to know, because that will help me try and narrow down what resistor is burnt over here. So, it's a lot of boring stuff. I know I'm really good at doing all the boring stuff. It's not exciting. But if it helps you diagnose your piece, whether it be this toy chest or something else, that's the whole point of it. It's nice when the motors are labeled, because you can look that information up. Unfortunately, there are a lot of motors aren't labeled, and you have to guess by its dimensions. Going, okay, it's this by this, so it's probably one of these series. But FF motors are very common. They come from really small to really big. this way you can see. There you go. Trying to get to where the glare is less and the camera focuses. There you go. FF13SH. And then there's the logo for the Mubachi company. So this is an original to the unit. You can see that this motor is a round motor, and this one's what they call a square because it's got two flat sides. Looks like a square. So now I need to find a gear. Put this all back together, resolder the wires, and then play with the resistor. What I'm going to do is I'm going to disconnect the resistor, and I'm going to test to see what the voltage is where the resistor would be. And then if it's 9 volts, then I can use Ohm's law to figure out what kind of resistor I need to have a voltage drop of 3 volts or 4 volts, and then see if this actually works like it's supposed to. My concern is it's not stopping, meaning it's going in one direction, and instead of these fingers doing their job, it just keeps going, and that's probably why that broke. It could be wrong. I don't know. We're going to find out. So I'm going to pause it again while I get my gears back out and see what I have that's closest to that, so we can get that replaced. As far as the motor goes, I don't think there's any problems with the motor. What I think probably happened is it couldn't stop. So it was either trying to lift or lower the unit, and it didn't brake. These fingers right here would be the brakes, and these are the cams that run the fingers. So the motor's just running, but nothing's moving because it's in the down position or the up position, and it's not having power killed to it. So it's still trying to move the unit, at which point it goes to overheat. So like when I was holding this until it stalled, and it went from 0.05 of an amp, 0.03 of an amp, up to 0.6 amps, which is more than a half an amp. It jumped up 100 and almost 200 times its power draw unloaded, that it got really, really hot. Now, the wire gets really hot, and the resistor gets extremely hot, and that's why it burned. So that's my hypothesis. I don't know if it's correct, but we're going to find out. So first thing I'm going to do, we're going to get a gear, and we're going to build the box back together, and then I'm going to turn it on, or solder the wires, turn it on, and see what the power is there. Because what I can do is I can leave this box out so it's not engaged this gear, which is the lift and lower gear. You can see the fingers are moving. Hopefully you can. See, there's another cam. You can see the reflection of the light changing because the fingers are going up and down. And what I'm going to do is I want to see if this just tries to rotate in a circle. So I can have the box out here, and I can rotate it here, and then rotate here to indicate up and down, and see if it turns the motor off. If it doesn't turn the motor off, then I know either the fingers are bad or the components on the board are not reading the fingers, and we can continue to work our way through the process. It's not fast, it's not exciting, it's just the way it is. So, be back momentarily. Okay, I put it back together. I found a gear. So I've been letting it run for about 10 minutes just to see if the motor gets hot, and the motor's not hot. So I'm leaning away from the motor like I was saying earlier. But I did not have a gear with a fat, I'm going to zoom in, make it easier because light glare. If I hold it up at the camera, so we're going to zoom in and move the gears over. So I don't have a gear with a smooth nose like that. So, and then this gear has a smooth nose. It's the right size, but you can see it's much shallower. I'll just do this so you can compare them. You can see it's much shallower, and that's not going to do any good. It's right size. But in the gear kit, there was one of these gears, which is the right size. This gear is too big, but there's only one. And if you notice, it has the right size, but that's a gear. So that's a gear on top of a gear. It's called a step gear. Well, it works perfectly. So you can see the teeth right there. And you saw it was running, and I'll turn it back on. Let me put the wires back to it. So I'm using the step gear as the same spacer. The vibration is because it's vibrating on my counter. Because you can hear it's a lot quieter when it's not. It still makes noise because it's not under any load. I'm also running the motor probably at a slightly higher voltage than what it runs from the unit. So it's not the exact same gear because it's got a smooth nose. It has a step gear, but it's the same size. So the diameter of the gear, the outer gear, the diameter of the nose, and the depth of the nose is the same as the step gear, and it works just fine. I've done it before on many other pieces. I thought I'd have two gears so I could show you them side by side, but the Akui kit that I usually link from Amazon below, it's a brand new kit. I've only used one other set of gears out of it, which besides the one I used up here, it might have been the same gear, but there was only one left in the kit. So I can't show you the exact gear, and it would suck if this one broke when I pressed it on, because then I have to order another one and wait 2 days for it to get here. But it didn't break. Yay! So now we're back, and you're back up high, and I'm gonna throw this away. Don't need it. It's broken. All right, so that's done. Now let's figure out this part. I'm going to turn this sideways. I'm going to try and figure out this resistor. I don't know if the resistor is still any good, which is going to sound funny. Sometimes a burnt resistor will still have resistance. You can try and get an idea of what the resistance is. So let's fire up a multimeter here. And see if there's any resistance on this. So hold this side here and touch this side here. Oh, it's burned open. Oh, wait. Maybe I just don't have a good connection because it's crispy. Let me see if I can get a little bit better connection underneath the corrosion. 53 ohms. Approximately. Okay. Gives me a starting line. So based on the size, this looks like it was an 1/8 watt resistor, or maybe even a 1/4 watt at the most. So this is a 1 watt. And we know it's 53 approximately because it's been burnt. So the closest thing to 53 is going to be 47 or 68. In this kit, let's check this kit to see if it's any different. 47 or 68. Now these are much larger resistors, you can tell, so they can dissipate more heat. They can dissipate up to 1 watt. Anything above that, they'll start to change colors and look like that. We got 47 ohm, and yeah, so it's pretty common right there. I'm sure I could probably find a resistor online that's close to that 53, but I'm going to go with it's probably not, and I'm picking up it's because it's burnt. So I'm going to do a 68. I'd rather be slightly over than under. So we're going to start with that. So, and I'm going to use a slightly fatter resistor. I don't know what caused it, but just in case, it's caused by a failure in this mechanism, I don't want to overheat. It gives me a little bit longer before I overheat the resistor, basically. Just a little bit of a fail-safe. So turn on my soldering iron. But like I said, I'm going to hook all this up, but I'm not going to put this in here. I'm going to manipulate this manually to make these do what they need to do to send the signal to those wires over there. So while my soldering iron heats up, we're going to prep everything. First thing I'm going to do is make some room. So I'm going to put my meter out of the area. We're going to put these up, get them out of the area. The hammer was for slowly smacking the gear on. If you've watched other videos, you've seen me do it many a times. So I just want to make a little bit more usable space. I have a big old bench, but it always seems to get encroached with stuff. I have spare parts over here from houses I've been taking apart, throwing away, that are parts houses. I got a house over here I got to fix that I can't figure out how to get apart, which does happen. You can usually figure everything out, but sometimes you get stuck. So I'm going to get rid of this resistor. Right there. This wire was the wire for the other side, and I'm going to have to get my solder. I took my solder out because I've been working on my display, and I'm making a big platform, and I can't bring the platform in here. It's too big and too heavy. So my solder is still sitting on the platform. So if you're a regular viewer, or just periodically as you need something to figure out, I'll have in October, possibly November, I will have a video of my new display. Can't do it prior because I have an open house and some of it's going to be in a magazine, and I don't want to spoil it prior to everything, so I can't do anything. I can't show anything until October, which is fine. I'm not done. I'm just getting into the mocking up the top of it stage and running all the wire, hence the solder that's not in here. But like I said, in the meantime, strip some wires. We'll get them all prepped up. The red wire is connected to this, so this is part of the cam system. There we go. Wires are stripped. Now I don't have to pause it while I go grab my solder. Be right back. Okay, I'm back. I just didn't want you to have dead air for 15 seconds while I went across and grabbed everything. So. Right now I'm just tinning the connections. Will that stand? Oh, that will stand. Okay. Especially the motor, because these connections are not pretty. They're old. Matter of fact, let's get that broken piece of wire out of this one. I'm not touching it with my finger, trust me, that would be bad. Okay, wires are tinned, except for this one. Alright. You're trying to solder multiple connections. So, we've got a resistor and a wire. One of them always wants to come off, so I'm just going to clean off the solder pad and try and do this again. There we go. Alright, so new clean solder that's not discolored from the heat of the burnt resistor. And now we're going to solder the one hot wire on. And now we're going to try and solder on the resistor. I'm going to pull the resistor up against the solder and the other wire, so hopefully we can get them both soldered at the same time. I need more space. Let's see if I can push it. Yeah, that didn't work. Resistor soldered, wire is not. Now let's try this again. There we go. Wire soldered, resistor soldered. Alright, now we can solder the other wire to the other side of the resistor. Going to shorten the lead. I know this is all exciting. If you're still watching, hopefully you're not super bored. Something to hold this because it can get hot. Not a lot of wire, so it's going to transfer the heat really fast. There we go. Okay, so those are done. So now the main power wire, which goes to here, this finger, and the resistor that goes to the switch and to this little circuit board here, those are done. Now we just need to solder the motor back on. And remember, the red was on the bottom, green was on the top. That's the stripe. There's the red. There's the green. Okay. Get that up and out of the way. Alright, everything's moved out of the way for the most part. So for all the screws and pieces to the unit. Now, let's grab this. So the finger is breaking connection to the music box, not to the motor. Now it did. Here's the thing, it's only turning in one direction. I know why it's only turning in one direction. I got it. I turned off my soldering iron. I just didn't want it okay. I understand it now. I do. Okay. So I was under the assumption the bar would go up and then it would reverse and go down. No, the bar just spins in a circle, hence this long slider, the two of them. So it goes up, down, up, depending on the position of the switch. The switch turns off, but this keeps going until this is in the bottom position, which would be like the factory reset on some of the animated pieces from Lee Max, or I don't think Department 56 has any, but if you have any other pieces where you turn it off and then it keeps running until it gets to its 0 position or its starting position, that's what this is doing. It is running until it gets to a starting position. So now, resistor is not hot. That's good. Let's check the voltage, since I said I was going to check the voltage. So I know it works. I understand how it works now. I have a better understanding, at least. So now it's time to voltage test it, see how much power is getting to the motor, and then see if that is the correct resistor. I think it is. That motor is spinning fast. I know with the gear reduction it slows it down, transfers to this, which makes it slower, transfers to this, which makes it slower, and you get your gear reduction, so you decrease speed, increase torque. I understand the whole principle, but it sounds like it's spinning too quick. Now, I could be wrong, and that's what it's supposed to sound like, and it won't be near as noisy when it's encapsulated inside of a box. So, we're just going to kick this out of reset, and I want to see what the power is going to the motor. 6 volts. And if I remember right, 6 volts, 6.6, so it's close, it's 6.6. That's really close to its optimum running speed per its diagram on the manufacturer of the motor's website. So, I was saying 5 volts, but after I read it and it said 6 is the optimal, at least if that's what I remember, that's probably what it is. So now, let's see if we can slide this back together. Let's first disconnect power, because we'll be manipulating wires, moving them out of the way and stuff, and I really don't want one to come off an arc. Won't hurt you, but it will hurt the little pieces of equipment inside. And now we just got to feed this thing into its position, which, there we go. So I turned the bar because it's getting caught on the T, so rotating the bar pulls it down flat. Now we need to put the 4 screws in, and then I'm going to turn it on again while it manipulates the bar. Once I screw it down, of course. So yeah, this is a complicated but simple piece. When I say complicated, it's complicated. You see all the pieces that move, what it does, all the little connections, but it's pretty simple in its process. It uses a multi-position switch, which is common. Most switches are off-on, just have an off-on pull where it's one connection, and then it passes wire through. This has 6 solder pads, so in one position it's on, the other position is on, but it's also opposite. When it's one side's on, there's another set of connections that's off. and that's what they do. That's why there's so many wires going to this switch, is so it can still reset it even though it's off. It turns off the music box and the animation, but keeps this going till it turns itself off by breaking connection at the 0 point. So very simplistic, just complicated to those who don't do the mechanical stuff. It's just a mechanical off-on switch versus a micro switch or a reed switch on more modern stuff. So, all right, so it should turn on, hit the reset, and turn off because I kicked it out to get the motor to fit. I want to feel the resistance. And then, and all I was doing with this was feeling the resistor if I could feel any heat. That was it. It wasn't helping it along, just feeling the resistor. Want to see if I could feel any temperature changes, because, you know, things can get hot. Now that it's under full load of the mechanism. It's not under full load because it's not lifting or lowering the unit. So even though the switch is in the off position, if you have this type music box, maybe not this specific one, but this style, even in the off position, it has power. Just be aware of that. It's always got power moving through it. A lot of things, when you turn it off, the power at the switch is off and you don't have to worry about it anymore. This has power constantly. It's always going to have power sitting here waiting for you to manipulate the button, but it's also, in case something gets jarred, it can reset itself. I don't even think that was a real word now that I'm thinking about it. Ajarred? So reassembly is the opposite of disassembly, like most things. Yeah, it's a good thing I turned the power off because, you know, something conductive just landed on the unit, not on the circuitry, but something conductive did land on it, which is a spring. And I'm going to leave the bigger resistor in there just because it's a bigger resistor, which means if something fails, it would be longer before the resistor fails. I know the resistor sometimes can be used as a fuse. I don't think it was used as a fuse. I think because the gear broke, I think it was just turning. The motor just ran all the time. So when the gear broke, it couldn't reset, so the motor just going. And then the resistor got hot because it's not designed. It was only designed, it's a momentary. It's only designed to run for a moment, meaning up and then back down. So in the course of its play, it's making one revolution of the shaft, a couple hundred revolutions of the motor, or probably a couple thousand to be honest. So yeah, not too bad. Now I do need this in the up position to reassemble this. I think. And maybe not. Let's see. Getting all these springs to align is going to be fun. That's 1 and 2 and 3. Oh, and 4 is really far off. All right, let's back it out some. There's 4. All right, those reset. That is set, and this one is now set. There we go. The reason I say I might be able to do it is because it does have the notches for me to put the screws in. Yeah, let's try and open back up again. All right. This is going on upside down. So there's a flat side and a round side. And I didn't pay any attention, but I think the flat side goes in and the round side comes out. Yeah. Come on. There you go. Let's try this again. I should have turned it off when it was at the top. But I was testing its reset and didn't think about the, oh, you got to put it back together part still. There we go. Now it'll stay together because one of the bars is now on. There we go. So now the basic music box is back together. Should have, power port stuck inside. Didn't think about that. So when you assemble this, make sure your power port's accessible, meaning that you don't put it inside the unit. Maybe lay it on the other side. There we go. I have to unscrew that completely so I can get this off of the finger. Like that. Yep. Learn from my mistake. Don't assemble it with the plugs pointing down. Here we go. Alright, let's make sure the wires are out of the mechanism because I want to fire it up before we stick it back into its actual container. And make sure this thing does what it's supposed to do. Hey, I couldn't call that a success. Looking, this has a little metal pin that went up inside his body that looks like it's sheared off. I think the metal pin was an alignment, so you know to point it this way. Alright, so now I get to spend the fun part in, get that back out. Remember, because it's always got power. Also, I can't drop it in there, well, it's, you know, inside. Now I get to spend the time in getting this back inside the box and getting that fed through those holes and getting everything screwed in like it's supposed to be. Getting all these pins knocked in. You can tell I'm looking forward to it. But before I do that, I'm going to reassemble the characters and let them sit. She's got two holes in her head. The edge of this ribbon was inside. Interesting. So, I'm going to pause this while this cures. It's probably going to be stupid of me and I should do it, you know, after, but I don't want to get glue on the lid because the lids might be in my way. So So I'm going to do it now while I have full access to the characters. So I'm going to let this sit for like 15-20 minutes. Usually it's faster, but better safe than sorry. So for those who don't know this, Enesco, which made this music box probably 100 years ago. I don't think there's a date on it. I already checked. Actually, it looks like there might be a date on it. It looks like it's handwritten. No, it's a person's signature. License on the Walt Disney Corporation, Mickey Mouse Club March Musical for Enesco. Anyway, for those who don't know, Enesco owns the Department 56. So if you are like, it's not a true piece, they own the Department 56. So if you didn't know that, there you go. Their music boxes are always very ornate and generally a pain in the behind to work on. This one's not so bad once you figure out the trick. It's actually a lot simpler than it looks. The hard part is just getting it apart. You saw the difficulty of disassembly. So, yeah. Knocking the hinge pins out, probably one of the best way, and then unpressing the lid pins. Technically, you can take it out without doing that. It's just going to be a lot harder. Either way, you're going to have to unpress these or possibly break the pivots here, which I don't want to break because they're plastic. So metal can be repaired. You bend it, you can straighten it. You break a pin, you can replace it. So go with the metal parts. But yeah, for those who don't know it, Enesco, and of all the music boxes, which I've worked on several, the Eiffel Tower, Pete's Dragon, the Left My Heart in San Francisco, with the trolley car, and I think there was a couple more in between. There were some I couldn't show on camera because they played real copyrighted music, not just the tones, the tone generator. Their older music boxes are very mechanically inclined. They generally have a minimum of 2 motors. This one has 3, as you saw. So they're pretty neat. This one's pretty neat the way it's done. Not a fan of Disney, like I said, but it's still a pretty cool piece. Just because I don't like something doesn't mean I can't appreciate it. So I don't care for Disney, but I appreciate this design. This is a really cool design. If this had something else in it, like Hot Wheels or just basic junk, it would be really cool to have. But what would it play? So you have to look at the other side of that too. But just the way they did it, the toy chest or the old style chest, which I'm sure many folks had them as a kid, whether it be domed where it's the short way or domed the long way. Old toy chests and stuff, I know I did. Had several of them. I even had flat top chests, which just recently got rid of because they were old and the wood was rotting. But as far as this, it's very busy, but very clean. So you can see all the different toys, and it's a toy chest. Should be busy. Why there's a telephone in it, I don't know. Other than that, the rest of it looks pretty standard for a toy chest. The way they have it set up is pretty unique. They don't use micro switches. They don't use reed switches. They use literal cammed fingers or points like they would be in your car. And that's really cool, which means they're serviceable. A micro switch breaks, you have to replace it, and you have to get the exact same size or it won't fit. This is a bar of metal with a contact. You can clean it, replace the contact, and fabricate a new one out of a thin piece of metal and a contact. Yeah, it's old school because of its age. Old school to me is better. It's more busy. You saw the gears and the mechanisms, but it's much more serviceable. There's no brain on that circuit board. There's a control chip. There's a potentiometer. There's a transistor. There's a couple of diodes. So 1, 2, 3 diodes. So it's just basic stuff. And all that does is regulate the speed control for the motor. And it's regulating, it looks like it because there's two sets of wires coming out of it. I think it's regulating the speed control for the music box motor right here and the lift lower motor. So that's what I think it's regulating, just based on the way the wires come out. So, but anyhow, like I said, I'm gonna let this sit. Yeah, Mickey still moves. We're both solid, but I'm gonna let this guy cure, and I'm gonna reassemble it. And when we come back, we'll see it working in all its glory. So I'll return momentarily, because I think this video is pushing like 90 minutes now. I don't want to waste any more of your time. Appreciate you watching what you have, and we'll be back momentarily with a, hopefully, completely fully functional, operational, and reassembled music box. Again, reassembly is just a reverse of disassembly. Drop it in, line up your stuff, stick it through, screw it in, screw the bottom in, all those holes, and then carefully press the hinge pins in and these pins. The easiest way to do it, well, I don't know how I'm going to do it until I do it, but I'm going to try using a pair of pliers. Now, if you're afraid of marring, which is a good possibility, you can put heat shrink over these and protect them from marring. Give you an example of things that, so I got another set, but that's what I do with these. You can see the heat shrink, because I don't just hold wires with this. I actually will, like, oh, I got to glue this, and I'll clamp this onto her bow and hold it if it wouldn't stick. So my helping hands over there all have heat shrink on the jaws. This one does too. This one doesn't, because this one I just use for wire. This arm's missing because it's actually two. This used to be a magnifier. Just found it easier to have it with two closer than this long bar. I have put tape on these, but I'm going to see if one, they're going to give me the right angle. If they do, I'm just going to put heat shrink on them, heat it up. That way there's no marring surface. So I can press through the pinholes. That's how I'm going to do those. The hinge pin, I'm going to try and press in and wiggle it, and then probably use either these or these to walk it all the way in. Because I don't know if you ever pressed on something that thin, sometimes it goes through your skin like a really dull needle, and then it hurts like hell. So we're going to try to avoid that. So, but anyhow, so I'm going to let this sit for a little bit, and I'll return. Running music box, go over some basic stuff, and then I can send this back to its owner. They should be really happy that it was repairable. I'm happy that it was repairable. And it was an experience. It was more complicated than I thought it would be, but very simplistic at the same time, and I'm really impressed with the mechanism they came up with. So, alright, return momentarily. Okay, so the toy chest is back together. I know why that resistor burned. Basically, the motor that lifts this is under an immense amount of stress when it's back inside this box. When it's outside the box, it's not under as much stress, and I think it's because when it goes up, it's on those bars with the springs, and it has a little slack, and it's rubbing the sides. But you can hear the motor straining. I've taken it apart a couple of times, tried adjusting it, putting it back together. I can't get it not to strain. Even with lubrication. I didn't lubricate the sides because that's going to collect a lot of debris, and you're going to start seeing it around the edges of the platform. But I think that's the reason why is this thing has huge power draw to get this thing to lift. To lower it doesn't. And to make the characters move, it's fine. But let me show you. It's plugged in. Oh, and I glued Mickey back together. There you go. And we turn it off. Ta-da! So, if you have this, it's not that hard to take apart. It looked hard because I've never done it, but since I've had to take it apart a dozen times to try and get the lift motor to not strain as hard, and it broke the first gear I put in. The very first gear I put in, it snapped it, because of the strain. I took it back apart. I cleaned the armature, the shaft, not the armature, the shaft that the gear is pressed on, and put a new gear on, and it's been working fine ever since. I think that when I pressed it on, it probably fractured the gear, because that's the problem with pressing, because you have to tap it in with a hammer. So anyhow, flip it over. So when you take it apart, you don't have to remove that screw. You can see how it's recessed in. You can see the white. That's just one of the 3 screws that holds the music box mechanism. You could kind of see the dent right there, and there's another one under sticker. So there's a boss or a casting for the other 2, but not for this one. And I'm wondering if these were supposed to be knocked out, meaning that it's got a ridge. I wonder if it's supposed to be knocked out so all the screws were visible. It'd be stupid to take them apart, because then it, well, falls inside the unit. So if you're taking it apart, you need to unscrew these 4, these 2, and that ring, which that's what it looks like, not on there. So it's just a little ring with 2 little grooves in it. There you go, kind of see the top and the bottom there, that you can put a screwdriver, really small screwdriver in, really thin needle nose pliers, or a spanner plier for snap rings. But you do have to do that, and you also have to pull the hinge pins. You do not have to pull the pins here, but you do have to pull them here. And I didn't push this one in all the way. So you do have to pull these hinge pins. Use a drift punch or even a toothpick. You can push it out a little bit, and then use some small needle nose pliers to pull them out. Do not lose them. Once you do that, the lid's free. When you unscrew these 4, and these 2, and these 2, and that nut, you can push this in, or grab it with a pair of thin pliers, and same with this, so that way when you slide the unit out, these don't catch in the respective holes they made for them. It's relatively easy. Once you get them inside the unit, you can just literally wobble, and it'll just come right out. Very simple. And then you can address whatever's wrong with it, whether it be a broken motor, a broken gear, multiple broken gears, multiple broken motors, because it's got 3 motors and multiple drives. It's very simple to work on. It's a lot easier than it looks. Once you have it out, the lift springs, the lift springs, the springs that help lift it up, take out the 2 screws. There's little notches for a screwdriver. Take them out, take the plate off and the other plate off, and then you can separate the base from the top, where all the stuff is, except for the drive for the characters, and then just twist it so you don't break the wires. If you break the wires, just solder them back on. I mean, they broke on me. Thing's old. It happens. Don't lose the springs. So that's why you saw me put them inside the box here, so I wouldn't lose them. And then you can service it. It's very simple to take apart. It's very straightforward. The cam mechanism with the shafts and the little fingers that touch the contacts, it's very herky compared to what they have on today's stuff, and it works. It's a mechanical switch that uses the motion to tell it to turn on or off, and it doesn't matter. The motor only spins in one direction, so when it's at the top, it goes, so if this is the top, it rotates, now it's down, then it turns back on and rotates up, and that's the lift and lower. Like I said, it's a very simplistic design, very easy done. The hardest part is the gears. I bought 2 different gear kits, and luckily the gear for this was in each one. So I'll link them below. But only had 1 in each one. One had the teeth on it, and the other one didn't. The one that didn't, I had to put a little spacer in. That's the one I ended up using because it didn't have a nose, but the ring was still the right size. And that's only because the one with the teeth, well, it broke. It lifted it once and then it snapped, and that was it. So again, that could have been me pressing it on. That's the problem when you press things on. You have to tap it on with a hammer. If it goes even a slight out of it straight, it can crack. And I'm sure that's what happened. I didn't see a crack in it, but the gear didn't grab. It just spun on the shaft, so it couldn't lift. So, but other than that, it's not terribly difficult to work on. It's fragile because of its age, and it's plastic, and they don't make the stuff anymore. I mean, you saw in shipping, some of the pieces came off. So if you have this piece and it doesn't work, hopefully this video will help you. It's not too terribly hard to work on. You just need a screwdriver. It doesn't have to be electric. You can use an old-fashioned, well, not a blade, but there you go, cross tip. And do it manually. You'll need 2 different sizes. One for the little screws and the little screws, and then one for the bigger screws. And then the screws on the inside are the same size head, but they're a different shank. So don't mix them up, because the ones on the inside are slightly narrower than the ones that hold the base on, which are slightly fatter. And then the screws that hold in the different components, they're also number 2, and they're all different. So the ones that hold on the motor plate have a flat top, and the ones that hold the side on, where you take it apart to get the motor out and the gears, has a button top. But if you just set them aside in little piles and know which pile's what, there's only 3 to 4 screws that hold everything together. So I mean, you got 4 of the small screws, which these screws are the same. You have 4 of these screws. The motor that lifts and lowers, that gearbox, has 4 of the same screws. When you take it out to open the gearbox, it's got 3. It's very simplistic. It's not overly difficult. So, but it's done. It's ready to go back to its owner. And hopefully this was educational. This was a pretty neat piece. Like I said, I'm not a big Disney fan, but this is a pretty cool little piece. I remember growing up as a kid, I had a toy chest too, but my lid wasn't bowed this way. The lid was bowed that way, which is just a different style. And it's kind of reminiscent. You open it up and you see all your toys inside. But outside of that, it's a pretty cool little thing. I'm hoping I don't get copyrighted for the music box, since somehow real recently a lot of the music that music boxes play are getting me hit left and right. But outside of that, that's why there's a video I could never post, because even if I posted it without the monetization or anything, it still came back copyrighted. I'm like, it's a music box. I have no control over it. So I can't show you how to fix something that plays music if I can't play the music. And on these, you don't have a choice. When you give it power, they play. When you turn it off, they stop. It's not like Limax where you have a volume knob or you can turn the volume down. So hopefully it's educational. Any questions or comments, you can go ahead and put them below. I try to respond to people as fast as I can. Usually I'll give you a little like once I read your comment, whether it's respondable or not. And then I'm going to go ahead and put this back in its little box, which is right here. I don't know, does the box have an age on this? I don't even remember if we found an age on this. Copyright Walt Disney Company, Elbro Village. Yeah, no age. Huh. Well, it is what it is. So. Yep, and all 4 characters do what it shows on here. He goes up and down, he moves back and forth, head turns, and she spins like 270 degrees. So, but yep, like I said, pretty cool little thing. I will put this back on the handle and then put this back in the box, and she should be good to go. So, thanks for watching the Mickey's Magic Toy Chest Deluxe Multi-Action Musical. Got a big name. So, alright, till the next repair. Have a good one.